Hey everyone, and welcome back to this class, the NumPy stack in Python. In this lecture, we are going to talk about some different ways we can generate arrays of data. Sometimes we just need some arrays to try stuff on, like in this course. One way you've seen so far is that I can use np.array and pass in a list. So for example, like this. Notice how this is somewhat inconvenient because I have to type in each element manually. What if I wanted an array of size 100? What if I want them to contain random numbers? So this lecture will show you how to create arrays. The first thing I'll show you how to do is create an array of all zeros. So that's just the function zeros. You pass in the size. So that gives me a vector of length 10 with all zeros. I can also create a matrix of size 10 by 10 of all zeros. So just like that, we have 100 zeros in a 10 by 10 matrix. Notice that the function still takes in one input. It is a tuple containing each dimension. There's an equivalent function that creates an array of all ones. So for example, O equals np.ones, 10, 10. Now we have a 10 by 10 matrix of all ones. Now suppose I want some random numbers. For that I can use np.random.random. So let's try to create a random array of size 10 by 10. So that's just a bunch of random numbers in a matrix of size 10 by 10. One thing we can quickly see is that all these values are greater than 0 and less than 1. Whenever we talk about random numbers, you should be interested in the probability distribution that the random numbers came from. So this particular random function gives us uniformly distributed numbers between 0 and 1. What if we wanted Gaussian distributed numbers? NumPy has a function to do that too. So let's try that. So it's called rand_n. Let's make it 10 by 10 again. Okay, so this fails. It tells us an integer is required. The function was right, but what we passed in was wrong. Now oddly, the rand_n function in NumPy takes in each of the dimensions as individual arguments, while all the others we talked about take in tuples. So the correct way to do this for only rand_n is to pass in each dimension separately. So that works. These numbers are from a Gaussian distribution with mean 0 and variance 1. NumPy arrays also conveniently have functions for us to calculate these statistics. So we can call g.mean, that gives us the mean, and g.var gives us the variance. So we can see that those are pretty close to the true values.